When a decision is taken for oncological surgery, it is crucial to know the size and location of tumours beforehand. In addition, it is important to assess the amount of the resected liver tissue and to know about the vascularization of the affected liver segments. Syngo CT Liver Analysis provides you with a guided workflow for an in-depth analysis of liver volumetry. It takes just 6 simple steps to assess the vascular supply areas of the liver and compare the resected and residual liver volume for planning of liver transplants and tumor resections. This movie will show you how to evaluate CT datasets with Syngo via CT Liver Analysis. First, make sure that the study is correctly assigned to the CT Liver Analysis workflow. Otherwise, click the right mouse button and select Open with CT Liver Analysis. The first step of the workflow allows an individual phase selection. Since the various anatomies of the liver are more visible in different phases, the software provides 6 segments for the segmentation of the following structures: liver, tumor, portal vein, hepatic artery, and bile duct or MR segments. Just make sure that all the appropriate phases are correctly allocated. Otherwise, simply assign the dedicated series by dragging them from the series navigator to the corresponding segment. Bear in mind that the same series could be allocated to different segments. Thus, for example, it is very common that the portal venous phase is used for the segmentation of the liver, the hepatic vein, and the portal vein. Once you are ready, confirm by clicking on the Finalize icon and go to the Step 2, Phase Registration, where a rigid alignment helps you register the anatomies from the different series. Select the phase options you need to align. In the most typical case, only the portal vein phase has to be aligned with the arterial phase, so only one option is available. In case you are using just one phase, for example the portal vein phase for LIV, HV or PV, no alignment will be necessary. Since the bile duct series also has to be aligned here, 2 options are available. Simply align the series by visually adjusting the color overlay over the original series. Move the images on any of the MPR segments or rotate the overlay by dragging the white circle to ensure that the liver anatomy fits together. When all phases are correctly aligned, click on Step 3, Liver Segmentation. In this step, an automatic segmentation of the liver volume has already been done. You can manually optimize the segmentation if needed. Start using the 3D Correct tool to perform rough changes, since your correction will automatically be extended to the neighboring slices. Use 2D Correct for fine-tuning, where you only want to modify the currently displayed slice. If you are satisfied with all of the inputs made in Step 3, go on to Step 4, Lesion Segmentation. Define the tumor, if any exists. This step is optional, and it is only active if a CT phase was assigned to the tumor segment in the phase selection step. The lesion segmentation is performed semi-automatically by drawing a line that crosses the lesion. You should start and finish the line out of the visible border of the lesion. The contour of the lesion is calculated, all relevant parameters are displayed on the text box, and a finding is created on the Findings Navigator for further archiving. If manual correction is needed, click on the Modify icon of the mini toolbar on the bottom of the segment and redraw the parts of the contour that you want to correct in order to add or remove regions for the segmentation. Subsequently, the calculation of the vessels can be started in Step 5, Vessel Segmentation. After deciding on the target vessel, simply set an initial marker on the corresponding main vessel. In case of hepatic vein, portal vein segmentation, you need 2 markers for each vessel to achieve the dual volume segmentation result. If manual adjustments are needed to be done, notice how you can delete or correct the label of individual vessels. Alternatively, on the MPR segments, you can add or extend segmented vessels. Click the target vessel to set the starting point. An interactive line is displayed between the starting point and the mouse pointer to show the course of the newly added vessel segmentation. Add new points and double-click to complete. In the next step, Vascular Territories, you can classify the vascular and liver anatomy based on the prior vessel segmentation. A segmentation based on the hepatic vein territories is especially helpful in case of hepatic lobectomy, for example when planning living donor transplants. A segmentation based on the portal vein territories could be useful in case of segmental resection, often required in tumor surgery. To classify the vascular anatomy, select one segmented vessel after another and label the vascular tree either in the MPR or in the VRT. The labels are displayed in the mini toolbar with different colors. Press the Calculate function to start the calculation of the vascular territories. They will be displayed as a color overlay of the corresponding territories over the VRT as well as MPR segments. The last step, virtual planning, offers you a virtual resection to simulate the surgical planning. With the object navigator displayed in the right side of the screen, you can hide and show the structures that you previously segmented. Just use the default presets or define your own using the corresponding checkboxes to display the structures you want to consider for the surgery planning. Then, simply draw some contours that delineate a plane in the MPR segments and click on the Plane function. The same can be done on the 3D liver surface in the VRT segment. You can further adjust the generated surface by just dragging the grey contour in any of the views. Additionally, you can modify a safety margin around the lesion for better planning of the resection volume. Both of the volumes delimited with the separation surface are quantified and displayed in the Object Navigator. Also, the functional volumes are calculated by subtracting the tumor volume from the former volumes. All of these results are all available on the dedicated report template. Open it by clicking on the report icon on the Patient tab. Here you will also find the lobe volumes calculated in the previous step. Saving and archiving this report and the results series is as easy as completing the workflow by clicking the Save and Send button.